What's going on, everybody? Welcome back to another video. This video is going to be a little bit different. It's kind of a tiny series that I'm going to input in the differential equation page. This series is just pretty much background information for you to at least take a look at or have some sort of intuition about when we're dealing with ODEs and PDEs, because some of these concepts we use them, but we never really discuss about them in your typical lecture, mostly because they're like very short and then they're just easy to go over them like really quick, and it just gets over your head really easily. So this video is here to kind of like clear things up or help you out. So this video we're talking about linearity and the principle of superposition, and we're just gonna go ahead and get started with linearity. So linearity is one of the major concepts that we use when dealing with ODEs and PDEs, and there's a lot of functions that follow this concept known as linearity, with ODEs and PDEs being the ones that we just discussed, derivatives, integrals, and like just a bunch of functions that are said to be linear. And so what does it mean to be linearity, or for there to be linearity? Well, if you're given a system and we're just going to have where we have some function x, and then we just put it into some, just it has like some sense, it does some things, and it just outputs a function y, then we call that a system. And so as this system is said to be linear, it follows two rules: the homogeneity and the additive property. And so, like I said, the system is like a function. So you put in something x and it outputs something else y, and that can be, that like little confidential box can be whatever, as long as it follows these two rules, like I mentioned, derivatives, integrals. Those can be inside the confidential box. And so we're going to discuss about homogeneity and additive property, what they mean. And so suppose we have a system in which we get some input x and it outputs y, and let's say we multiply the input x by some constant c. And so, oh, actually, yeah, I'm only going to show you the output function. So let's say we input something x, and then it outputs like a half or a sinusoidal wave. So there's the output function y, and so we multiply by some constant c, and we input that new input, which is x times c, and it outputs the same thing, y, times c, then the function is said to be homogeneous. And so what that pretty much means is we put in input x, we got y, which became a sine wave. Yeah, sine wave from 0 to pi over 2. No, 0 to pi. 0 to pi. And so now we multiply by some constant c, we'll get an output cy, which will pretty much be the same thing, except it's multiplied by some constant. And again, it's the same sinusoidal wave, it's just multiplied by some constant that's typically the amplitude. And so the additive property, this one's a little bit more straightforward. So if we're given this system where you input x and it outputs y, then we can input x1 and get y1, and then input x2 and get y2. But if we input x1 and x2 added together, and we get the output y1 plus y2, then the system obeys the additive property. And if it also obeys the homogeneous property, then this obeys linearity. And so, like one of the examples, again, I'm only showing you the output functions. So I'm not going to tell you what the input is, but the output. So let's say y1 gives you a sine wave that's from 0 to pi, and then the other output y2 gives us another sine wave that is from pi to 2 pi, and then if you add them together, you just get a simple sine wave from 0 to 2 pi. So yeah, the linear property is pretty much the homogeneity and additive property combined. So let's say we have some function that we're going to call L, and it can be whatever, and that is the L is pretty much the confidential box. It does things. And so you input c1 x1 and then c2 x2, and if you get c1 l x1 plus c2 l x2, then this is the linear property, and this is what the principle of superposition is. So it follows this principle, and this actually helps us combine solutions into pretty much have like one solution. So if you do like ODEs, usually when you have a solution, you have like C1, Y1 plus C2, Y2, instead of just having a solution Y1 and solution Y2. And so like that's what I'm actually going to be discussing in this following slide. So we were given that Y1 and Y2 are solutions to the differential equation as shown here. So we have second derivatives, first derivative, and a single derivative, all multiplied by some functions that are all equal to 0. Then we can say that y is equal to c1, y1 plus c2, y2 is also a solution to the differential equation. And so instead of having two separate solutions, we just have one combined solution that encapsulates both of them. Obviously, it's not only for second order differential equation, and it's not only for two solutions only. It can also be three solutions, four solutions, as many solutions as possible, and it can be any order derivative possible as long as it obeys linearity or the linearity property. And so to like show you why the solution y is equal to c1 y1 plus c2 y2 is a solution. Well, if we're given the differential equation that was in the last slide, and then we plug in that solution that we claim to be true, then we can say that the derivatives and partial derivatives of obey the linearity. So we can take the partial derivatives and or derivatives depending on what y is separately. So like the second derivative of c1 y1 plus the second derivative of c2 y2 instead of the second derivative of c1 y1 plus c2 y2, we can separate them out. And so when we separate them and then we group them into C1s and C2 and then factor out the C1 and C2, we see that we have C1 times the differential equation that's similar to the very, very top one over here. It's just Y1, and then the other side will be C2 with the Y2 of shown here. And if we were to just say that we made C2 equal to 0 and then C1 just regular constant, then we can solve that. Y1 will give us C1 Y1, and then if we make the C1 equal to 0 and then C2 just be any other constant, then we can get the solution Y2. And so we can combine these two together, and then the solution will be C1 Y1 plus C2 Y2, which is just pretty much shows the argument that I made like in the last slide. And so yeah, that is pretty much it. Hopefully this gives you a little, or helps you. Hopefully this makes a little bit more sense when we talk about superposition and linearity, and then why is it that we can write a solution as the sum of multiple solutions. Again, this is kind of like why we do certain things when we solving ODEs and PDEs, and this becomes major in PDEs, because even though this is similar to like an ODEs, PDEs, we are starting to get more complicated. Instead of finding one particular solution or like one solution, in PDEs it is possible to find infinitely many solutions, and we have to figure out if these are all linear functions or obey the linear property, linearity, and we can just encapsulate them all into one thing and making our answer and then solving much more easier. So yeah, I'll see you guys in the next video.